Hydrodynamic Study of Enayam Coast. Abstract. The role of the fishing port may be considered as the interface between the netting of the fish and its consumption. Hydraulic design of harbor facility is governed by complex coastal environmental parameters such as waves, currents, winds, and sediment movement. Hydraulic model studies are essential for the design of coastal harbors. The paper includes the hydrodynamic study of Enayam in Tamil Nadu and designing of the fishing harbor. Hydrodynamic study deals with the bathymetric survey, study on tide, wind, wave, etc. The bathymetric survey was carried out using MIKE21 software. Wave and wind direction were found from the wind rose diagram and wave rose diagram respectively. The wave height was determined using wave atlas and matrix analysis. Keywords: fishing harbor, hydrodynamics, bathymetry. Introduction. The coast, also known as the coastline or seashore, is defined as the area where land meets the sea or ocean, or as a line that forms the boundary between the land and the ocean. In planning a small fishing port along sandy beach, the most important points to be taken into consideration are how to prevent shoaling of the port entrance by drift sand and how to eliminate adverse effects of the structures on coastal topography such as downstream erosion and excessive accretion at the updrift beach. Movement of sea bottom materials is very active in the littoral zone, and even a small-sized fishing port must be designed to avoid littoral sand deposits at the port entrance. Hydrodynamic study deals with wave direction, wave height, wave frequency which has been obtained from wave atlas. Wave direction was identified and the percentage frequency of occurrence of wave for each month is studied. Wind wave model of the study area was generated. It will give the maximum wind specification which is used for the harbor construction. Wind and wave data during monsoon and non-monsoon period were collected from Wave Atlas and Global Wave Atlas, and also the soil profile details were collected. Based on these data, wind rose diagram and wave rose diagram are plotted. The dead load, live load, and seismic load are considered during the construction of harbor. Understanding marine hydrodynamics can help us to design better ocean vessels and to understand physical ocean processes. Studying marine hydrodynamics provides a greater understanding of a wide range of phenomena of considerable complexity involving fluids. Hydraulic design of harbor facility is governed by complex coastal environmental parameters such as waves, currents, winds, and sediment movement. Hydraulic model studies are essential for the design of coastal harbors. Hydraulic design of layout and the major components of the harbor is important step in development of fishing harbor. Harbor layout, length, and alignment of protective breakwaters, location of various wharfs, jetties, hauling facilities, safe parking area for the fishing crafts in the harbor, and dredging requirements for maintaining depths are decided through hydraulic model studies. Studies are generally carried out using physical or mathematical modeling techniques. The objective of the paper is to study the hydrodynamic characteristics of Enayam coast using MIKE21 software. MIKE21 is a computer program that simulates flows, waves, sediments and ecology in rivers, lakes, estuaries, bays, coastal areas, and seas in 2 dimensions. MIKE21 can be used for design data assessment for coastal and offshore structures, optimization of port layout and coastal protection measures, cooling water, desalination and recirculation analysis, environmental impact assessment of marine infrastructures, water forecast for safe marine operations and navigation, coastal flooding and storm surge warnings, inland flooding and overland flow modeling. 2 Study area. The area chosen is Enayam, Tamil Nadu. Enayam is located 32 kilometers west of district capital Nagercoil and 741.5 kilometers from the state capital, Chennai. Villages near Enayam include the Jayadevan, Midalam, Painkulam, Kilayur, Thothur, and Palur, Kurungal, Kalankadu and Unnamalai are other nearby cities. It is located on the coast of the Arabian Sea. A satellite map is shown as Figure 1. Fishing harbor is situated at 8°1252.89 N latitude and 77°1138.95 E longitude. Wave direction from month of January to December were identified and the values were noted. People in Enayam also support the upcoming fishing harbour as it can boost up the employment in that area. Maximum wave height is observed at the month of November. Hydrodynamic study and bathymetric survey was conducted in the proposed area. These data were transformed by MIKE21 software. Considering the soil profile, foreshore and offshore profile have been identified and studied. It showed that for a thickness of 1 m, loose to medium dense silta sands was observed, up to a thickness of 3 m dense to very dense sand, and for a thickness of 4 m very weak sandstone, and finally up to 6 m weak sandstone was found. When considering soil profile for deep waters, it shows that the area has medium to dense silta sand up to a depth of 4 m, dense sand clay up to 8 m, and very dense and sandy clay below. Enayam is located on the basement of the Kanyakumari district coastal belt. It consists of charnockite, granite, gneiss, leptonite gneiss, peninsular gneiss, laterite, and workali, sandstone. There are several indications of numerous episodes of deformation, which caused repeated folds, faults, joints and fracture. Systems. A preliminary study of material sources has been performed in order to analyze available materials for the construction, distance to the quarry areas, quality and nature of the materials. Visual recognition shows granite and gneiss quarries with good quality and extensive availability in neighboring districts of Kanyakumari. 4. Methodology. A general hydrodynamic analysis is one of the key steps in safety assessment of a structure in waves. Here the software used for hydrodynamic study is MIKE21. Using MIKE21, bathymetric survey is carried out. After the bathymetric survey, a near-shore spectral wave formulation is carried out to produce a spectral wave module. This gives the accurate coastal region where the harbor can be constructed. A mathematical study of the wave is also carried out by matrix analysis and formation of wave rose diagrams. Maximum wave height and period can also be identified by matrix analysis. Wind analysis is carried out with the help of Global Wind Atlas. B. Bathymetric study. Bathymetry is the foundation of the science of hydrography, which measures the physical features of a water body. Hydrography includes not only bathymetry, but also the shape and features of the shoreline, the characteristics of tides, currents, and waves, and the physical and chemical properties of the water itself. Steps to be carried out. 1. Bathymetra setup. Setup of bathymetra by importing geographical data with soundings based on a survey or digitized from nautical chart. 2. Creating the bathymetra. Nautical chart of the Enayam coast is identified from the Nautical Chart of India book. Based on the sea chart, we define our working area in the bathymetra editor. Defining the working area with projection system of UTM Zone 43 in MIKE21 software. Add the geographical coordinates, longitude 77.11416666666678 and latitude 8.1502126691711138. Easting and northing will appear automatically as per latitude and longitude specification. Easting is 732,944.457033082 m and northing is 901,513.64653750 m. Grid orientation will appear too by latitude and longitude. Import digitized shoreline data, land.xyz, and digitized water data, water.xyz, from GEBCO General Bathymetric Chart of the Oceans in ASCII files. Convert the ASCII files into .xyz format by extracting it into Notepad. Import these data from Background Management in Work Area. While importing, remember to convert the projection system to long/lat. For defining the bathymetra, select New from Grid Bathymetra Management in Work Area and import the base file and drag mouse over points of interest. Selected points are now changing color. Finally click on Import from Background once more. Interpolate XYZ data to grid points. Save the bathymetra specification file and load the generated DFS2 file into the grid editor. Bathymetry of the proposed area is obtained. The digitized bathymetry is saved as setup file in MIKE0. Now create new project by selecting near shore spectral wave. A dialog box will appear for giving the specifications. Accept the boundary condition of offshore. Mic automatically generates the parameters from the bathymetric data. Input data for offshore. Type of boundary condition version 1. Boundary data type constant values. Significant wave height, HM02. Mean wave period, TM7 SEC. Mean wave deflection, MWD 240 deg. Directional spreading index N-5. Max dot deviation from MWD MDWD 30 deg. See matrix analysis. Wave direction, wave height, and its frequency is studied from the wave atlas. In wave atlas the directions are represented at 10 asterisk intervals. The inclination at Enayam is given from 120 asterisk bearing to 300 asterisk bearing. Either from map or from the latitude and longitude value of Enayam coast, corresponding grid is identified I.E, grid 6. Matrix is obtained from the graph plotted and the total percentage frequency of each month is obtained. The percentage of occurrence per day is also calculated for each month by the equation. Percentage frequency at specific wave height asterisk no of days in month asterisk 24 divided by 100. The total percentage of occurrence per day for each wave height is obtained for every month. This value is plotted to obtain a graph against wave height and percent frequency. Probability of occurrence of wave for each wave height is identified and a graph is plotted using this probability. The cumulative probability for each wave height is obtained. The standard deviation for above wave data is identified by finding the mean and variance. Wave directions. The bearing value of Enayam falls in between 120 deg to 300 deg. So the maximum value of wave direction for each month is identified from the wave atlas. Corresponding to this wave direction a graph is plotted against wave height and percentage frequency for each month. V. Conclusion. The coast of Enayam located at a region of longitude 77.11416666666678 and latitude 8.1502126691711138 is studied for the hydrodynamic characteristics. Hydrodynamic study is carried out by Mic 21 software. Bathymetra of the proposed area is found using Mic 21 and the depth of ocean were identified. A near-shore spectral wind wave model was also generated to find the maximum wind wave conditions of the coast. Matrix analysis was done for the region by the help of Wave Atlas, which helped in identifying the frequency of occurrence of wave in each month, its probability of occurrence with respect to wave height, etc. From the bathymetric study it was observed that the critical range of wave lies between 240 to 280. And the total percentage frequency of the wave was found out to be 940.